Hey everybody, it's Mr. Mott. What we're going to do is go through how to draw Lewis dot structures. You'll need your periodic table or one handy where you can find the group numbers. And if you remember the group numbers, the A groups tell you how many valence electrons are present. All right, so we'll start out with a good example of water, H2O. All right, so this is the method that Ms. Bram uses, and I prefer this method to other ones that I've seen, but there are certainly multiple ways of sort of looking at this. So what we typically do is look at and try to find out the total number of valence electrons for the molecule. So when we look at hydrogen, it's in group 1A, so it's got one valence electron. Per the formula, there are two of them. So we're going to multiply that by 2, and then we're going to add the 6 valence electrons from oxygen, because oxygen is in group 6A. So that means that we have a total of 8 valence electrons. And just to keep the numbers down, we divide that by 2. So we have 4 pairs of valence electrons. And so then what we need to do is choose a central atom. Most molecules are going to have a central atom, and then from my experience, usually it's the one that we have less of, and so we only have one oxygen. So what we do is put oxygen sort of in the middle, and then we put our other atoms or elements on the other side. And it doesn't really matter where you put them because we're going to use the Lewis dot structure to figure out shape eventually. All right. So from what I do now is I'm going to start putting my pairs of electrons around the central atom and see how if we fulfill the octet rule. So 1 pair, 2 pair, 3 pair, and 4 pair. All right. So we have 4 pairs around the central atom. In other words, we have 8. And so what we notice around the central atom here is that we have an octet. So that's part of the Lewis dot structures, is that atoms tend to be more stable when they have an octet or 8 electrons around them. Now, you'll notice we don't have an octet around hydrogen, but hydrogen is one of our exceptions. One way to think about it is for hydrogen is that it's just too small of an atom to fit 8 electrons around them. There'd be too much repulsion. So we don't have octets around hydrogen, but that is actually okay. So that would be our sort of Lewis dot structure. Typically what we do is that we take our bonded pair of electrons, so like our bonding pairs of electrons are here and here. And so instead of writing them sort of as dots, we usually write them as lines. So what I would then rewrite this as, I would write H with a single line representing the bonding electrons. And then I would maintain the unpaired or the lone pairs of electrons as dots on the outside. So this would be my final answer for my Lewis dot structure. All right. If we look at something where there might be multiple bonds, we can look at CO2. Follow our same procedure. Carbon has 4 electrons, group 4A, and we have one of them. We have 2 oxygens, each having 6 valence electrons. So we had 4 plus 12 would give us 16 electrons, or we'd have 8 pairs of electrons. All right, so I'm going to choose carbon as my central atom. Doesn't always work this way. It's really a problem-solving thing, but most of the time it works. And again, let's put in our lone pairs around the central atom. So 1 pair, 2, 3 pairs, 4 pairs. And then I'm going to start putting my other pairs around the oxygens. So I've used up 4, 5 pairs, 6, and then 7, and then 8, sort of splitting them up. Now, around the, let's see here, around the central atom here, we have an octet, but we don't have an octet around the oxygen. So if we were to kind of circle here, the 2 lone pairs and the bonding pair, we only have 6, and that's the same on the other side. So that's not going to work. So what we have to do is we have to think about moving some of our lone pairs of electrons around the oxygens or the carbon to try to maintain the octet. Now, I think the thing to think about is that carbon, it already has an octet. So if we start adding electrons in, maybe from the oxygens, that's going to bring more electrons around the central atom than we want. So we don't want to do that. So we're actually going to move the some electrons, some of our lone pairs of electrons around the carbon and just make them bonding pairs. So if I take and it doesn't matter which we did, take some bonding pairs of electrons, like let's say this unbonded pair on top of carbon to the center, then we're going to have an octet for the oxygen on the left. And then to get an octet for the oxygen on the right, we're going to also move another pair of unbonded electrons around the carbon to the center. And so here's what that's going to look like when we rewrite things. So the carbon is going to have its original electrons around it. And then we're taking that electrons from the top and the bottom and moving them to the center. The electrons that oxygen originally had as lone pairs remain there. And then now we have more bonding pairs of electrons here. So here are bonding pairs of electrons. And now we have an octet around everything. So if we were to look at, so here's an octet for the oxygen on the left. The carbon has an octet with these shared electrons. And now we have an octet here. So very happy, carbon's very happy in this case. So then rewriting this, I would say I'm going to have my oxygen, carbon, oxygen. My lone pairs of electrons stay as dots. So we'll leave that there. And then my bonding pairs, each pair we're going to represent by a line. So we have 2 bonding pairs from carbon to oxygen on each side. And so that means we have what we call double bonds. And so this would be our arrangement here for carbon dioxide. All right.